Okay, so it's a hard act to follow because I loved all the stuff that Will said. It was actually really, really good. It was all the stuff that I really enjoy about engineering. So hopefully I can kind of complement that with how we can go about shortening feedback cycles and how we can improve collaboration and testing and all that other good stuff in the next 20 minutes. So we are going to talk about a little bit about TDD. So the way we're going to work is a bit like this. So I don't know if you've seen these things on Facebook where it starts like an atom and then you end up at the universe. We're going to do that, but it's just not going to be as spectacular. So we're going to start with TDD, a TDD, and then we're going to go into a big picture. So it's not really like atom to universe, but it's going to be more showbiz. We're going to go talk about the TDD cycle quickly. I'm guessing we haven't got a huge number of developers here. If you're development areas that you hand up, guess we've got a few. Okay, that's good. We're going to talk about ATDD, acceptance test-driven development, which is really what the core of this is about. That's things like shared understanding, that's things like shared ownership, and a test-first approach. We'll talk about the ATDD cycle, which kind of sits around the TDD cycle. And then we're going to talk about the big picture. So, who I guess everyone else is UI, UX, product management. Nods, good. Anyone from BA sort of areas? No? Okay. Gloss over the BA bits. So, let's start small. Why TDD? Test-driven development. When we write code as an engineer, what we're interested in is solving the problems that we're given by the business requirements. What happens if we just start smashing in code is that it all starts to go a bit wild. So TDD solves some problems. It's not clear exactly what needs to be done before writing the code. You have an idea, you start doing some stuff, we might need some of that, maybe we'll do a bit of this, but it's a little bit wild. It's not clear whether all of the code you're writing meets a known requirement. Is there value in writing code if no one's asked you to do it? It's debatable, right? It's not clear whether the code base already meets that requirement, intentionally or otherwise. If you're writing code to meet a requirement, but actually it already does it, someone's already done it, another team has already done it, someone's done it historically but in a completely different way, you need to know that, otherwise you're wasting valuable time when you could be developing features. Long feedback cycles. So ideally, and the kind of the crux of this whole talk is how do we shorten those feedback cycles? How do we know as soon as possible whether it's good or bad? And then documenting the code. You don't want to write comments in your code. Comments are fungus. You change code, you don't change a comment. Maybe you do, maybe you don't. How do you know? You've no idea. So you could read a thing that says, this whole method does this, but actually the method's completely, maybe it's not even used, maybe it's been deprecated, maybe it does something completely different. Developers are not well known for their meticulousness in documentation, or maybe it's somewhere completely different. Maybe it's in Confluence or another kind of wiki, or maybe it's in OneNote, and you make a change, or you make it quickly, or you just make it. You can't be asked to update the documentation, so then you end up with two completely different states. Test-driven development documents your code. It documents what it does because those tests run every time you make a change. So the key side effect is that you implicitly, by going through a TDD process, create and maintain a regression suite. So every time you make a change, you know that you haven't broken anything, and you know that when you start, your code base doesn't already do that by accident or otherwise. And when you finish, it does do it, and it does it properly. So TDD cycle, we'll go through this quite quickly. Red, green, refactor. I think everyone's probably heard the terms. You write a test that exercises the functionality that you're going to implement, and then the test fails. It's red. If it's not red, your code base already does it, and something's gone wrong. You then make the smallest, simplest change, the smallest possible change to make that test pass. That doesn't mean that you go off and you spend 3 hours implementing stuff. You make the smallest possible change, and the test passes. And it might just simply be returning like a literal value. Your test says this should return 2, return 2. That's it. And the idea is you iterate over it. The test passes, it's green, that's good. You might then want to, as you go along, then restructure your code, not the behavior, just the way that your code is written, to do exactly the same thing in a more maintainable way. So that's what we call refactor. And the unit test obviously should still pass, because if you've changed something and it fails, then you've changed the behavior, not just the way it looks. Cool, makes sense. So, ATDD, Acceptance Test Driven Development, is a larger process that kind of sits around TDD. TDD is a very, very developer-orientated approach. It's involved with the code, and it's about basically declaring what you're going to do before you go and do it, so that you know what you do is just what's required and no more. So ATDD, the flow of requirements is sometimes a bit disconnected. I'm sure we've all seen this. I'm sure we've all seen, we want this thing, and it goes to, you know, a vision document, and then it goes to a BA, and it goes to a development team, and they go, oh yeah, I think actually what we want is this thing. And those two things are completely separate. We've all been there. If you haven't been there, I'd like to talk to you, because I want to know how you did it. Sometimes you can't take stories into a sprint. I'm going to talk very much in the kind of Scrum methodology here. If you want to talk about other methodologies, grab me afterwards. Poor requirements definition. So we want a thing, we want this thing, we want it to be shiny, excellent. But what do you want it to do? So sometimes you get to the point where you want to deliver this, and you want to take it into a sprint and develop it, but you can't, because you just don't know enough about it. Rework when requirements aren't implemented. So you work on the thing, and then someone looks at it and goes, oh, no, that's actually not what I was after at all. It's a waste of everyone's time. Acceptance criteria. So we want it to do this. It's a variable quality. What you want is to know that what you've delivered is exactly what was asked for, basically. Sometimes you need to translate these things, transform them from one format into another. You take a 17-page vision document and you turn it into, you know, 17 individual functional tests, which it takes a person to interpret that. Collaboration between three amigos, so our product owner, whether that's a BA, a dedicated product owner, whatever it might be, someone looking after the test concerns, and someone looking after the software development concerns, sometimes is inconsistent. And those three things are absolutely core to developing software, quality software. Mini waterfall testing, longer feedback cycles, we kind of develop, okay, go and test it. Doesn't work. And second-class citizens. So quite often QAs, BAs, UI, UX are often second-class citizens in development teams. The software engineers, the ones who go, stand back, hold my pint, I'm going to go in and I'm going to do this, and you're going to love it. Doesn't really work. So, after laughs, everyone knows those people. So there are three kind of key things that ATDD brings us. A shared understanding, shared ownership of what we do, and we take a test-first approach. Those three things give us, this is the magic preachy bit, high-quality software. They give us high-trust teams and high-performing teams. Sounds very preachy, but it's actually true. In my personal experience, having done this, it really does work. So we're going to talk a little bit about shared ownership, and no clock, so I'm just going to carry on until someone hooks me off the stage. We'll talk a little bit about Scrum and Agile. You're just going to wait. Get off the stage. Scrum and Agile, again, if you want to talk about other development methodologies, come grab me afterwards. I'm more than happy to talk about that stuff. But Scrum itself makes some very specific statements about ownership. And it says that Scrum recognises no titles for development team members. And the key thing that here is not these particular rules, it's that a development team is a team of people, a group of people, whether they actually work in the same team, under the same line manager, or in the same building, whatever it is, even if you work across different companies, the idea is that you, as a development team, you are developing something, a feature, a product, whatever it might be, that ultimately is going to go to a customer, whether that's someone on the street, or whether that's another business. Ultimately, you are all developing a product, so you should all be 100% involved and 100% behind that. So, everyone is developing it, regardless of what you actually do on that team. Everyone is developing. There are no sub-teams. You don't have a testing team. If you ever hear the term, we'll come to this in a sec, it's dev complete now. There, you go and test it. Then again, I think it was like alarm bells should ring, and it's true. It's done when it's done, right? The individual development team members, they might have specialised skills. Of course they will. You can't have everyone being a jack of all trades. It doesn't work. But those people should all be first-class citizens within a team. There are no heroes. This is your hold my pint, I'm going in kind of person. The team is responsible. And that might be an extended team, that might be UI, UX, that might be your product managers, it might be high-level vision stuff, it might be low-level, deploying stuff in PowerShell. Everyone is developing that product and making it something they can be proud of. They should feel a collective sense of pride. If you've been there, if you felt that, you know what I mean. If you haven't, find a new job. Or change your current job. Change the culture. There is no dev complete. Something is done, a product backlog item, whatever it is. A feature is done when it's proven to meet the acceptance criteria, not when you finish writing the code. Not when you as an engineer go, yep, done, checked it in, CI/CD is running, going to do something else. It's not done. It's done when that team, extended or otherwise, is happy that it's good. There are no handoffs in a high-performing team. You can't necessarily avoid all handoffs, but basically, if you can do everything within that team, there's no point at which you need to go, I need to stop this, put it down, wait for someone else to go and do something before I can get back to it. So, ideally, the fewer handoffs you have, the more high-performing your team will be. And that's really kind of back to classic XP practices. If you've got everyone you need at the same table, then, and even using the same keyboard sometimes, then brilliant. There are no misunderstandings, you get stuff done. There are no second-class citizens in a high-trust team. Everyone on that team should feel that they contribute equally to whatever feature, product, whatever it is that you're developing, and share that same amount of pride in it. So shared understanding, I'm going to skip through this bit a little bit because I've got about 3 hours of material and only 20 minutes to deliver it in. So how do we make sure everyone understands what is actually required? What are we doing as a development team? Everyone on that development team, extended or otherwise, needs to understand it so that when we've done it, they can look at it and say, yeah, it's done. We love it. We're really proud of it. So we tend to look at things like writing requirements in a common format so that we all understand it. It means we don't have to interpret, we want a shiny to we want a control on a page which has a specific behavior when in this view or on our mobile view it does it. Those two things are interpreted, right? One to the other. What you want is the same thing that you can define, test, implement, test as you go through. We use a ubiquitous language. A ubiquitous language is, a classic kind of concept. It's been around for literally decades. Where we share the same terms. If I say to you, we need to change the product name, that's going to mean something different to every person in this room. For me, this is a product, but this is not a product that I can actually sell. This is a product which means it's a group of variants which come in sizes and colours. For someone else, a product is something that they're developing. A minimum lovable product, for example, is a product of something. So using ubiquitous language means that we all understand straight away what we mean, and we don't have to interpret or get it wrong. So we keep a domain dictionary. We say, okay, when we say products, what we mean is this. Great. That allows us to incorporate that into our test automation, which means that we can say product, But actually there's some code that says, okay, we're going to instantiate a product object, and it's going to have an ID, and it's going to have a name, and it's going to have some other stuff, and you can start to build up personas and all that kind of stuff. Talk to people. It's so obvious. If you've ever been involved in a kind of back and forth of email or Slack or Skype for Business, God forbid, or whatever it might be, where you're basically just toing and froing, and actually if you just walked over to that person and said, I just need to know this thing, is it this, this or this? And they went, it's this, because it changed last week. Done. Talk, everyone understands, everyone feels good about it. There's so much less opportunity for hostility, all that kind of stuff. So, common format that we can use for these things, given when thens, I'm sure we've all seen this, given this state, when I perform this action, then I see this result. Pretty simple. The key thing is with ATDD is that you can take those and you can define your high-level requirements like this. And you can take those high-level requirements and you can actually turn them into executable tests with exactly this format. Not interpreting them in any way, actually taking this and putting it into something like SpecFlow, let's say, or writing your own framework that says I'm going to set up something. I'm going to create a customer. I'm going to log into that customer's account. You know, I have a logged-in customer. They are going to add a funky key-backed T-shirt to their bag, and then I should see that product in the bag. This is obvious stuff, right? It says nothing about the implementation whatsoever. It's talking about a behavior, and that behavior can go from there right down to the unit test. If I go down to a unit test of this, then I can say, okay, I need to instantiate an object which represents a customer. They're going to have an ID, an order history. They're going to have some other stuff. When they add something to their bag, I'm going to instantiate a bag, or bag, basket, elsewhere, but you know, you instantiate a basket object, add a product to a particular ID and a particular variant, and it's associated with that customer. Then I see this result. Yes, it's in their bag and it's associated with that customer. I've taken that from a high-level requirement that just says, I want this to happen, to an actual executable requirement. A requirement I can execute again and again and again and again and again as I make changes to the code base, and everyone understands it because it's the same thing, end to end. So, to reiterate that, a GWCA, given when then, it's a logical function. It doesn't have to have any actual executable functionality. It's a logical function. If anyone studied symbolic logic at university, you will understand this. Begin to believe I'm the only person who did. It was really good. You provide some known input, you invoke an action, and you expect some kind of known output. Simple as that. That's a logical function. The thing is that is what a unit test is. We take some input, some state, we execute an action, and then we examine it, we assert an output. But so is an acceptance test. If we do something like SpecFlow, for example, then we're doing exactly the same thing. We're just doing it without understanding what's in the code. We're just automatically calling our code base. We're saying, do this thing based on this input, and what's the state afterwards? It's the same thing, which means that a functional requirement is the same, and basically, therefore, turning functional requirements into acceptance tests, into unit tests, into working software can and should be done from exactly the same set of criteria. And I do mean the same words, the same everything. It works. It works if everyone works as a team, extended or otherwise, and uses this same kind of language. Everyone is singing from the same hymn sheet, no one gets the words wrong, and no one sings out of tune, and we all love that one. So, TestFirst development. I'm going to do this quickly because I want to do the last slide in a bit more detail. It basically just means that we do what we need to do, and we don't just start gold plating and adding stuff and going, oh, we need all this shiny stuff, because they're going to ask for it one day, but when they ask for it, it's something completely different, and we have to find it and take it all out again. Oh God, no, they're going to notice. Well, it's going to take us longer. It's a way of being confident that what we're writing, from the very first line of code that we write, is exactly what's required, and that's a good feeling. And it's all about understanding what you're doing and why. No one wants to be like a mindless drone. People want to understand, software engineers are smart people. We employ them because they're smart people. and therefore we want them to feel that they are contributing their best self to whatever product they're developing. So let them understand why. And if everyone understands why, then what we come out with is something we can all be proud of. Acceptance criteria is absolutely key. It's defined by the development team with the product owner. It's a shared thing. We're going to cover ATDD in a second. It's business readable. Gherkin is a popular format for this, given when then is part of that syntax. It's written from an outside-in perspective. Classic TDD goes from the, I'm going to start at the very smallest class level and work my way out. Fine, but a better way to do it, arguably, holy war, is outside in. So I am a consumer of the system. If I go and do this thing, then what are the other things? What are the collaborators that need to be in place behind that to make it happen? And that means that we're thinking about the customer journey, not how we implement it technically, and that's very key. Expectations of behaviour. So we talk about what we want the behaviour to be, not the implementation. We should, in theory, be able to change the entire implementation of the back end and go and write it in a completely different language, and all of our functional tests should still pass, because nothing should have changed in terms of behaviour regardless of how we implement it. So the ATD cycle, discuss, distill, develop, demo. So we had the red, green, refactoring, TDD. We now have 4 things. When we discuss, the team starts to ask questions. You come to the team and you say, I want this thing. And they go, okay, how will that work? And what will it look like? And what about this other thing that you asked us to do? And what about this technical hitch that's going to stop us from doing that at all? And they might, from that, add new stuff to the backlog. So the team, the product owner, whoever it might be, might say, okay, well actually there's some other stuff. We add that to the backlog, brilliant. But they should, at this point, establish a shared understanding of what they want to do. They then distill it, so the team, again, extended or otherwise, formalizes that acceptance criteria. And they use something like Gherkin. So we talked about logical functions. We say this is what we want to happen, the behavior that we want to see based on the input we give and an action we take. They use a ubiquitous language, a language that both business and technical members of the team understand. It's the same words. And they don't include implementation details. So at this point, we still haven't written any code. We still haven't written any functional tests in actual code. We're just saying, if we do this, given this input, then we should see this other thing. It should, at this point, be ready to go. We should all know what we're going to do. So when we take it into sprint, it means we can just crack on, we can develop it. We don't have to stop and go, we don't really know enough about that. Let's wait for John, the product owner, to come back from holiday, and we can ask, and it just sits there on the board when they could be spending that time developing other features. Right? So then they develop that. They develop that into automated tests using, as we said, exactly the same format. If we can do it, then it means that there's no ambiguity about what we're testing versus what we've been asked to do, and therefore what we're implementing. We can use things like domain objects. We can say Jenny the customer, and we know that's a persona. It's agreed. It's in our domain dictionary. We can then go and instantiate that customer. And we know that it has all of these attributes. As a business user, you just want to know that it's a customer, she's bought this stuff, she's a student, she gets a 10% discount, whatever it might be. Same words, but we can use them in different ways. We add some technical scenarios. It might be request per second, it might be the utilization of the CPU, whatever it might be. So non-functional stuff. And those make executable requirements. Literally executable. You can hit run, and those requirements are executed on your code base, and you can do it over and over and over and over again. And when they come up green, you know it's doing what you want it to do. And then you demo it. So it might be that at this point you already know it meets the requirements because those tests are green, and those tests are exactly the same thing that you were asked for in the same words. You might do some exploratory testing, gamifying it, handing it over to another team and going, see if you can break it. And everyone goes, all right, I'm going to start writing little scripts. I'm going to pass in 2 billion and whatever string, 2 billion character strings and whatever, because that's what engineers enjoy. And And I do. And it's good fun. It's good fun. It's a high trust environment. You can hand it off to someone and say, go and break it. And when you break it, we'll all have a laugh about it. That's a high trust environment, right? And then your sprint review, show your stakeholders. Go, this is what you asked for. We know it does what you asked for. We just want to show you. And our TDD cycle sits in the middle of that. Automated acceptance, red. We implement it in the actual code. And then they're green on the way out. Everything inside is white box testing, so we know what the code is doing, we understand the code. Everything outside is black box testing, so we're testing it as a consumer. So the big picture in my last minute, this is my biggest and longest, and I have to tell you, my most ambitious slide I've ever created, with about 413 different animations on it. It's going to be wasted. So hopefully you're all familiar with this. This is basic, basic product management, product ownership type stuff. You have an idea, you prototype it. You test it. You have a feedback cycle. You improve your prototype, and then at some point you say, okay, we want to go ahead with this. We put it in the backlog of the development team. That backlog then goes through the process that we just talked about, and we start to build it. We build it, we deploy it, we measure it. We do things like maybe we do analytics, maybe we do MVT, maybe we do A/B testing, that kind of stuff. From those things, we iterate over it. So we say, okay, well, we can probably improve this in a very small way, and then measure it again. So it goes back into the backlog, we build it, we measure it, we iterate, so on and so forth. We also learn from our iterations and customer feedback and our beta testers, whoever those people might be. So from there, we pass it back into, oh, what if we did this other thing? That would be really cool. And so it goes on. So that kind of goes from qualitative over to quantitative, which looks like you have a rough idea, a non-functional prototype, so something like a mock or a wireframe, whatever it might be. What if it looks like this? Feel free to take the call, I can wait. A functional prototype, so this is ideally you start to get, this is probably your UI UX guys. This really should be your development team, so you're starting to come over onto this side and say, hey guys, get involved, what can we do here? This looks really cool. And they're like, yeah, this is brilliant, but you've forgotten this other thing that's like a major technical problem, we can't do it. So, okay, fine, so go back and loop around. You might do some A/B, MVT testing and gauge the response from your actual customers or from your beta testers or whatever. You might do a selected territory rollout. We certainly do that. We roll out to our smaller regions, and then we go out to our bigger ones if it doesn't all go horrifically wrong, which fortunately it doesn't. And then a full rollout. And then our ATTD sits kind of in here between our backlog and build largely. This cycle happens. Within that is our TDD cycle, and so we end up with our small. Yeah, and that is about it.